Alright, now we're going to do some problems where we pick the method of elimination or substitution based off the problem we have. Now, honestly, you can do either one on any problem, but some just set up easier for one or the other. So here's the first one we're going to do. So we've gone over substitution, we've gone over elimination, now we're trying to decide which one to use. And so when I see a problem like this, I know what I would do, and I hope you would understand why. I would use elimination because everything's lined up. Also, substitution would be quite difficult because I have to solve for one of these variables and none of them have a coefficient of 1. So this would be a problem where I would do elimination. So then I just need to pick a variable to get rid of. For instance, I could get rid of x if I were to multiply by -2 because it would create a -6x to go with that positive 6x. Now I got to do it all the way across, so I'd get plus 10y. And even right here, you'd be surprised how many students forget to do the last number. It'd be -40. Alright, so I'm going to take this equation away for a minute so we can focus on the top and the bottom. We're going to add so that the 6x and the -6x eliminate. So we're adding these equations. 6x and -6x is gone. 8y and 10y is 18y. 22 and -40 is -18. And now we've got that one variable equation that's easy to solve. Divide by 18, y equals -1. Now, remember, that's half the battle. Still have to go find x, so let's go back to that top equation, 6x plus 8y. But what do we now know? We know that y is -1. We know that it's supposed to equal 22. We get 6x minus 8 equals 22. We would now add 8 to both sides. We've got 6x equals 30. Divide by 6. And it takes us a little while, but we figured out that x is 5. So our answer is 5, -1. We chose elimination. Now, truly every problem is a substitution problem. What I mean by that is after you find, like after we found -1, we did substitution. But as far as the method to get started, we used elimination because everything was lined up. And that's number 1. Second problem I want to look at. It's y equal x plus 8. Followed by 3x minus 2y equals -19. Now when you look at this problem, I don't know what method you like best, but immediately when I have one equation that's already solved for one variable, that makes me think substitution. So I'm going to do a y for y swap. So as I follow the rule of the second equation, it's 3x minus 2, but I'm not going to put y in there. I'm going to use what I now know y equals, which is this stuff, x plus 8. Alright, so we're using substitution. Distribute minus 2x. Distribute minus 16. Like terms, x. What's left? Add 16. So x is equal to -3. Now, if you were thinking elimination, yes, you could have brought the x over and then got everything lined up yourself. But since it was ready to go with substitution, that's what I did. Now we're only halfway there. So, if y equals x plus 8, and we know -3 is our x, then we very quickly get that y is 5. And that's our solution for the second problem. We use substitution because one equation was already solved for one variable. Number 3. Y equals -4x minus 15. Y equals 2x plus 3. Now, truly everything is lined up, so if you want to do some sort of elimination, you could, or you could even move stuff around to where it's the normal lined up of x first, y second, number third. But I actually wouldn't use elimination at all. I would remember that if two things equal y, then they have to equal each other. So take out the middleman. This is substitution. Because what you're really doing is you're putting -4x minus 15 in here for y. You're putting this whole thing in for y. Or you can think of it as putting this whole thing in for y. Doesn't matter which way you want to think about it, but you're substituting for y. And now we're down to just good old algebra 1. Let's add 15. That'll give us -4x equals 2x plus 18. Let's subtract 2x. We'll get -6x equals 18. Let's divide by -6. And get x equals -3. So here we are. Now go back to either equation. This time I'll go to the second one because I seem to always use the first one. We now know x is -3. Two times -3 is -6, plus 3 is -3. So we actually get matching x and y values this time. These two lines intersect at -3, -3. So if they both equal y, they both equal each other. And that's a problem that I would do substitution on, even though elimination would be fine if you wanted to do it. Last problem. This is number 4. 2x minus y equals 18. X plus y equals 3. Now, if you were doing substitution, it'd be okay because you could solve one of these for one of the variables pretty easily. But because everything's lined up, and because right here I have exact opposites, I would just jump to elimination. I'm going to add these equations together. (18) and 3 make 21. (y plus y is nothing. 2x and x is 3x. Easy equation, divide by 3. Very quickly we have that x equals 7. Go find one of the equations. For instance, the second one was x plus y equals 3. We now know x is 7. So we could just subtract 7 to finish. Y is -4. The answer to this problem is 7, -4. We used elimination because we recognized everything was lined up. We recognized we had opposites, so we added. If we had same, like y and y, we could subtract instead. We've talked about that. All right, so hopefully that gets you kind of in the mode of recognizing when to do what if you have the choice. Sometimes I will ask you to substitute, sometimes I'll ask you to eliminate, sometimes I just want you to get it solved by one way or the other. So hopefully this helps you determine when to use which method.